Alright, this is Algebra 1, 2.1. I'm on page 64 in the book, so please follow along as I go through the vocabulary. And write our vocabulary. Here's our line whole numbers, and there's whole numbers right at the top of page 64. Whole numbers is a set of numbers, and it is the set of numbers that includes 0, starts at 0, 1, 2, 3, and so on. And the ... the 3 dots means that it continues that way forever, and there's no halves or decimal points in between. It's just the whole numbers starting with 0. And then integers is also a set of numbers, and it's on the same sentence as whole numbers. Integers now include, if you think of a number line, here's 0 in the middle. The positive numbers go to the right, and they go that way forever. And then the negative numbers go to the left, and they are -1, -2, -3, and they keep going that way forever. The positives. So the integers are the negatives, the positives, and 0. And the reason why I'm saying 0 and 0 is because 0 is neither negative or positive. It's right in the middle. So work our way down the vocabulary. Rational numbers, it's about 3/4 of the way down the page. It says an integer belongs to the set of rational numbers if those numbers can be written in this form, a over b. And basically, I remember it has to be a fraction. So here's some examples of integers. 1/4, because 1/4 is a fraction. 3 is a fraction because we can put a 1 under it and make it a fraction. So rational numbers are numbers that can be written as fractions. I'll write that so you can write it down in your notes. Okay. Opposites, and I'm trying to help you in the book here. I don't know where opposites is. Opposites are usually, like if one number is positive, the opposite of it would be negative. So I'll just give you, here's two opposites, 3 and -3. They're opposite of each other. So one's positive and one's negative. -7 and +7. Those are opposites. And absolute value is the distance a number is from 0. And usually absolute value is given with signs that are straight lines, like so. So I'm going to put one in here. This, if you see something like this, you would say, what is the absolute value of 7? Meaning, how far is 7 away from 0? If you were thinking of a number line and walking along the number line, it would be just 7 steps away from 0. So the absolute value of 7 is 7. Then we did the absolute value of, let's do -8. Okay, absolute value of -8 means how far is -8 from 0, and it's the same thing. It is 8 steps from 0, so it would be 8. So absolute value is never negative. Absolute value is always positive. And the last one, a conditional statement, and you know, there's some other words I'm noticing in here. The opposites was on the top of page 66. The absolute value is actually, you guys are going to have to, is a key concept box on page 66 that you guys need to write down, and it gives some things about absolute value, some examples. So make sure you get those in your notes. I'm not going to take the time to write those out. You guys can write those out. And a conditional statement, the bottom of page 66, it says, a conditional statement has a hypothesis and a conclusion. An if-then statement is a form of a conditional statement. The if part becomes the hypothesis, then the then part becomes the conclusion. So you have an example. Let's see, a conditional statement we're going to talk about is an if-then statement. So if this happens, then this happens. That's one of the things. If you study for your test, then your grade will be good. If you get your work done, then you can go out with your friends and play. I don't know, that's kind of a strange example, but anyway, there are some vocabulary, and there's a lot of words in this, so we'll see as we get going through this and doing the examples. So let's do that. So example number 1, graph and compare integers. It says to graph -3 and -4 on a number line, then tell which number is greater. So you have, a number line, like what's up on the front of the board in my room. There's 0, there's -1, -2, -3, -4, 1, 2, so on. And obviously mine on my board goes up a lot farther. And when you have to graph them, you only have to include the numbers that are needed. So -3 is right here, so graphing it means I draw it and I put a dot showing where -3 is. And then I put a dot here showing where -4 is. So that is graphing those numbers. Now we have to tell which number is greater. Well, there's a couple of ways to look at negative numbers. A lot of times people get confused because they think 4 is bigger than 3. But when you're dealing with negative numbers, of course, I like to think of money. I like to think of negatives as you owe money. So it is much worse to owe somebody, not much, but worse to owe somebody $4 than $3. So the number that is greater for you is -3. Another way to think of it is when you plot numbers on a number line, the number that is farthest to the right is the biggest number. So that's one way, and then obviously if it was the left, it would be the smallest number. So let's see what they did. They graphed it, and here it says therefore -3 is greater than -4. The -3 is the bigger number. So here's our guided practice. It says graph the numbers on a number line, then tell which is greater. So let's do it. 4 and 0. So like I said, what we're going to do is we're just going to go like this. 0, 1, 2, 3, 4. And so I'm graphing 0 and I'm graphing 4. And then we know that 4 is greater. So pretty easy. Their number line's pretty intense there. A lot of spaces in between. 4 is greater than 0. Number 2, 2 and -5, and this one's got to be a little bit bigger of a number line because I got to go from, let's see, so 0 here, 1 and 2. We only have to go to 2 that way. -1, -2, -3, -4, -5. So -5 is right there. 2 is right there. And here's what they're trying, 2 is greater than -5. And a lot of times people forget to look at the signs and they just look at the numbers and they think 5 is bigger. But remember, when you have a negative sign in front of it, the bigger the number with a negative sign, the less that it's worth. And there's their, almost right on our number line. So they agree with our statement. So number 3 is -1 and 6. And again, we'll do 0 right here. -1, -2. I suppose I could number by 2's. -4, -5, -6. -1 is right there. -6 is right there. And remember, the number that's farthest to the right is greater. -1 is greater than -6. 1 is not greater than 6, +6, but it is when we throw the negatives in front of it. And again, you can think like owing money also. And so then there's their version of that. Alright, example number 2 says to classify numbers. To classify numbers, when you classify something, you put it in groups. You put it in different situations. And what we're going to do is we're going to classify numbers into categories. We're going to say, is it a whole number, an integer, or a rational number? So a whole number is a number that, if you remember back in your vocabulary, it's either 0, 1, 2, 3, 4, 5, starts at 0 and goes higher. And there's no decimals. No decimals, no fractions. An integer are the positives and the negative numbers. Okay, all of them. 0, 1, 2, -2, all of those. And then also a rational number then is a number that can be written as a fraction. So let's see how they do this. I think they make a nice table. Yeah, so let's talk about why we're saying yes to certain things. So let's start with number 5. There's number 5. Is it a whole number? Remember the whole numbers were like 0, 1, 2, 3, 4, 5. So yes, it is. It's an integer because it's a positive number. It's a rational number because it can be written as a fraction, which is 5 over 1. So that's why we said yes to all 3 of those. Okay, point 6, is it a whole number? It's not a whole number, it's a decimal part of a number. It's not the whole thing. It's not an integer because it's not a negative or the positive, the numbers, nothing in between. And it is a rational number because point 6, the correct way to say it is 6/10, and 6/10 is a fraction. So we can write it that way. All right, -2 2/3. It is not a whole number because of that fraction on it. It is not an integer because of the fraction on it. And it's not in fraction form right now. You would have to do that half circle thing that if you've had me before, that's what I teach. It'd be 6, 7, it'd be 8/3. -8/3, and that is a fraction. You can have negative fractions, so yes, it is a rational number. Last one, -24. It is not a whole number because it's negative. It is an integer because it's a negative number, and it can be written as a fraction, -24 over 1. So then it would fit into that category. So classifying numbers, you're just telling yes or no. Is it a whole number? Is it an integer? Is it a rational number? Example number 3, ordering rational numbers. So here's an astronomy question. A star's color index is the measure of the temperature of the star. The greater the color index, the cooler the star. Order the stars in the table from hottest to coolest. So the greater the number, the greater the cooler it is. So that means we need to go from least to greatest. So what is the smallest number here? And one of the things that your book suggests to do is to make a number line. But I see all of these, I'm going to relate all of these like money. That is like 3 cents. This is like 21 cents. This is 9 cents. And this is 22 cents. But then to start with, I want to start with the ones that are worth the least. The least are the negatives, which are these. Did I say least to greatest? Are we supposed to go hottest to coolest? Least to greatest, right. So these 2 are the negative ones. Remember, the bigger 22 hundredths and 3 hundredths. 22 hundredths, 22 cents is bigger than 3 cents. So the bigger the negative number, the less it's worth. So the first one is going to be Shala. Is that how you say that? So I'm done with that. Then I go Rigel, because that's the next negative number. And then I'm thinking of this like money. 9 cents is the next one, going in order. And then Arneb would be the coolest one, since it has from hottest to coolest. The greater the color index, the cooler the star. Right, the bigger it is. Okay, it's hard for me. All right, there's their solution. Look what they do. They take and they graph the numbers on the number line, just like so. And then look, that automatically puts them in order when you graph them on the number line. And that's just another method. I like to think like money. It's just faster for me than making number lines and dealing with all of those decimal points. So whatever works for you, please use it. So there they are again. So let's check out some guided practice. It says, tell whether each number in the list is a whole number, an integer, or a rational number. Then order the numbers from least to greatest. All right, so let's start with 3. I'll go over here. 3. Okay, 3 is a whole number. I'm going to put W for whole number, I for integer, and R for rational number. That's pretty clever of me, isn't it? 3 is a whole number. It is an integer, and it is a rational number because we can write it 3 over 1. -1.2 is not a whole number. It is not an integer because of the 0.2. It is a rational number because we can write that. 1 2/10, we can write that as a fraction. And then, what is that, a -2? It is not a whole number because of the negative. It is an integer because of the negative, and it can be written as a fraction. Throw in a 0 or a 1 under it. Then the last one is 0. 0 is a whole number. It's actually the first whole number. 0 is an integer, and 0 over 0. I don't think it's rational. I don't think you can write 0 as a fraction. Let's see what they say. Oh, now we got to put them in order from least to greatest. So -2 is the smallest. -1.2 is next. 0, then 3. And when I get them, then I start thinking about it like money. Yes, yes, yes. No, no, yes. That's what we said, wasn't it? Yes. Only the rational. Integer and rational. Ooh, it said it is rational, so I guess you can write it. So let's note to self on that one. 0 over, well, I guess 0 divided by 0 is 0. So I see why they said yes right here. You can write that is. When you're dividing nothing, you get nothing. So, and there's them in order from least to greatest. Alright, so let's check this out. Number 5. This one. Find my pin. We're 4.5. Okay? It is not a whole number. It is not an integer. It is a rational number. -3/4, not a whole number, not an integer. It is a rational number. -2.1, not a whole number, not an integer because of the 0.1, but it is rational. This one. Is that all rational? Seriously? Well, I guess we'll see. Okay, negatives. The biggest negative is -2.1. Then the -3/4, which is like 75 cents. Then 0.5, which is like 50 cents. And then 4.5, which is like $4.50. So let's see what happens. No, no, yes. No, no, yeah. We got it. Look at that. And then when we put it in order, we are good. Way to go. All right, we're good. Let's keep going here. 3.6, look at all of these. Since they all have decimals, not a whole number, not a rational, not a whole number rational, no, they're all, or not, excuse me, not a whole number or an integer, not a whole number or an integer, not a whole number or an integer, not a whole number. So they're all rational. We can write every one of those as a fraction, and let's start with the money. What? -2.8 is the biggest in the biggest number with a minus, so it's the least. -1.5, -0.31, and 3.6 then with this. So first I look at all the negatives, and when you're in the negatives, the bigger the number, the less it's worth. I worked my way up, then I got to the positives. So let's see. Yep, I agree with that. And we got that one right. Way to go. All right, let's try it again. We're getting good at this. The only thing that is rational. That's only rational because it's not a whole number or a integer. That is rational. And this is an integer and rational. Remember, we learned and a whole number. We learned that from that last one. And putting them in order, there's only one negative, which is the -2/3. There's a 0, 1/6, and 1.75 because the whole number makes it worth more. That's what we did. And there's our order. Alright. So the last one of that. Okay, next one. Finding the opposites of numbers. So it says if A equals -2.5, then -A, and this is kind of a neat way to look at this. This right here, when you see a minus in front, it also means the opposite of. Let me show you with an integer. 2. Now, if I say -2, another way of saying -2 is saying, what is the opposite of 2? The opposite of 2 is -2, which that's what that is. So that is the opposite of 2. So what we can say here, when we see a minus in front, we can say the opposite of. So if A is -2.5, then what's the opposite of A? So what's the opposite of -2.5? Positive 2.5. So just kind of a play on words right there. So on B, if A is negative 3/4, then the opposite of A is negative 3/4. So remember, one's positive, one's negative. So now the absolute value, there's those signs that I was telling you about, which is right here. When you see straight lines, those are not parentheses. Those mean the absolute value. And remember the absolute value, and this is where that key concept box is, if you haven't already written it down. I'm on page 66 in the book. The key concept box talks about those absolute values. The absolute value is the distance a number is from 0. So how far is negative 2/3 from 0? Distance is never negative. You always have to, you know, when you travel, it's gonna show up on your odometer. You're never gonna go backward. Even if you go backwards, it's still going to register. So the absolute value is the distance a number is from 0. So let's look at this one. What is the this is asking us, what is the absolute value of 3.2? 3.2. That's how far it is if you were to walk from it to 0. Okay, example 6, analyzing a conditional statement. Identify the hypothesis and the conclusion of the statement. If a number is a rational number, then the number is an integer. Tell whether the statement is true or false. If it is false, give a counter example. Okay, so here's our statement. Here's our if part. So the if is just stating something. It's a hypothesis, and I've managed to lose my pen. Here it is. I'm sorry. Okay, so here's our if. If a number is a rational number, then the number is an integer. Okay, it doesn't mean always, but if it is a rational number, then the number is an integer. Tell whether the statement is true or false. So if you think about that, the number is rational. That's our hypothesis. Identify the hypothesis. So this part right here is the hypothesis. This part right here is the conclusion. All right? So the statement, if we can come up with, if it is false, give a counter example. If it is a rational number, then the number is integer. That means the only thing that's rational are integers. That is false. Because I can give you a rational number, 0.5, that is not an integer. So we disproved that statement. So let's see what they did. I think they used the same number. Okay, the number is an integer. The number 0.5 is a counterexample because 0.5 is a rational number, but it is not an integer. So you got to find something to disprove it, and if you do, then you know it's false. All right, so let's check out some guided practice. It says, for the given value of A, find the opposite of A and the absolute value. That's what this right here. They're asking us to find the opposite. This right here, they're asking us to find the absolute value. And I need you to be really careful on your assignments when you do this, so I know which is which. Which is the opposite and which is the absolute value. So you need to make sure you let me know, label them some way. Opposite for this one is negative 5.3. The absolute value of this one is 5.3. Remember, absolute value is never negative. And there they just have it in order. So what is the opposite of negative 7? Positive 7. What is the absolute value of negative 7? Positive 7. How far is negative 7 away from 0? So 7 and 7. Okay, what's the opposite of negative 4/9? Positive 4/9. And what's the absolute value of negative 4/9? Positive 4/9. And then if you've noticed, every time absolute value will always be positive. Identify the hypothesis and the conclusion of the statement. Tell whether the statement is true or false. If it is false, give a counterexample. Okay, so let's see if we can disprove it. If a number is a rational number, then the number is positive. Oh, I don't think. First off, here's the hypothesis. Okay, I'll circle the hypothesis and underline the conclusion. Okay, well, I can think of a rational, then the number is positive. How about this? negative 1 half. That's a rational number, and it's not positive, so that's false, because we just proved it right here by finding one. Number is a rational number. Conclusion, that means the number is positive. It's false, and their counterexample is negative 1, and we just chose something else. Number 12, the hypothesis, I'm circling that, aren't I? If the absolute value, pin was working so good. Okay, that's a hypothesis, then that's a conclusion. If the absolute value of a number is positive, then the number is positive. Well, the absolute value of a negative, that's a tough one. I think it's false because if the absolute value of a number is positive, then the number is positive. But the absolute value of negative numbers are also positive, like the absolute value of negative 3 is also positive 3. So I think, let's see, it's false, yes. And negative 2 is the counterexample. I use negative 3. Okay. All right, that is it for 2.1. Lots of notes on that. Sorry, lots of stuff. If you have questions, please ask. Don't just do it to get it done. Make sure you understand, and we'll see you next time.